Welcome to the annual 24-hour race at the Le Mans circuit in France. This programme is about how one of the strange ways history connects things is going to affect the way this race will end 24 hours from now. Because every year at Le Mans, the winner gets his picture taken as he crosses the line. And because of the weird way history has of turning things on their heads, that's why he's going to win. The winner is photograph winning because he's photographed winning. So in more senses than one, when this is all over, it's going to be a photo finish. Years ago, the race to put photography into everybody's hands got off to a rough start. The buckets of chemicals you needed to develop your holiday snaps. That tore when you tried to get them off the developer. Then came a breakthrough. A guy called George Eastman put film emulsion on some flexible stuff that had just been invented in 1895. Eastman then packaged this flexible stuff into rolls that you could easily load into his new pocket camera that would revolutionize the business of holiday snaps, called the Kodak. And by the strangest coincidence, the clue to where that new flexible stuff came from is in one of the first pictures shot with it, during a different kind of shoot. Now, all those Eastman photos of all those great white hunters up the jungle were only possible because of what the great white hunters were doing up the jungle, causing the great disappearing elephant scare of 1867. The reason? The market for ivory. It had tripled in the previous 30 years. England alone took £1 million of ivory a year. Work it out. 60 pounds a tusk, 2 tusks an animal, that's 8,333 and a bit dead elephants a year for England for fun. This kind of fun. Now, a good billiard ball was hard to find. You had to knock off quite a few elephants to get the right stuff, because a really good ball came from the centre line of a perfect elephant tusk. So the news out of Africa was not good for playboys of the Western world. Never mind the elephants. Then, in 1869, a couple of printers from Albany, New York, called Hyatt, came up with a substitute. It was cheap, it was indistinguishable from the original, and it eventually got used for this, because the ivory substitute was celluloid. One other celluloid product will give you a clue as to where it came from. The Hyatts also manufactured celluloid false teeth, which on occasion, as per the New York Times of 1875, tended to explode. What was causing all the bangs, and which when heated, squeezed and mixed with camphor turned into celluloid, was gun cotton. Specially treated cotton that made really good explosions. In the late 19th century, the new way to get more bang for your buck. So from then on, a lot more shooting went on. Now, it was a well-known mystery at the time that for those few a bullet just missed, you heard 2 bangs. One, the gun firing. The other, well, nobody knew. So a Viennese gent called Ernst Mach decided to find out. He used the way turbulent air affects any light shining through it to photograph a bullet in a high-speed airstream, and he saw what looked like a bow wave coming off the bullet's nose. Mach worked out that this shock wave propagated outwards faster than the speed of sound. So the first bang you heard was the sound of the shock wave. The second was the sound of the gun. 2 big deal things came out of Mach's amazing pictures. The first was the modern science of aerodynamics, without which these cars wouldn't look the way they do, move the way they do, maybe even stay on the track the way they do. The second was noisier even than this place, because once Mach had a photograph of shockwaves, he could look at how explosives happen, how the shockwave propagates, how the force is shaped, which meant, of course, that you could now, for the first time, plan an efficient explosion. Mach's shockwave mathematics helped make the atom bomb work. Now, the reason Mach had photographed shockwaves was so he could see them. Physical evidence was the only reality you could trust, he said. And even then, the way you described experience would still be relative to the context you were in at the time. So a 24-hour race would really only be a reference to what time meant on this planet, spinning on this axis, doing this sunset. Elsewhere, who knows? So even time and space would be constrained by your perception of it. You'll see what Mach was getting at if you take that kind of look at what's happening here. Oh, and I'm presuming you're not a racing driver. What I want to try and show you is how this looks relative to different experience. A pit stop and a wheel change is, for a professional driver, the slowest thing that happens at Le Mans. But if you were doing this, the whole thing would be just a blur of activity. It was for me, filming this in the pits for the first time. What seems to be happening is that you and I are processing the data coming in from this experience the only way we can, based on our normal modes of operation, which affect how we perceive the business of traveling on a racetrack at up to 150 miles an hour. We get overload. Everything's coming too fast at you to process. And on top of it all, you're doing it in the dark. So basically, you perceive everything happening faster than it really is. But for the professional racing driver, the effect is exactly the opposite. Distance measurement becomes extremely precise. Car in front. Car in front. Turn left. Turn left again. Now turn right. Time appears to slow down. He sees things we wouldn't. This is the world as perceived by the professional driver relative to his experience in races. Well, it's 3:30 in the morning here, and they've been at it for nearly 12 hours. Meanwhile, I presume all this talk about relativity means you know who was about to pick up on Mach's idea that there was no such thing as absolute space and time that would be the same for everybody everywhere in the universe. He was a chap who would have said that as these car drivers went faster and faster, time for them really did slow down. Einstein, thanks to whom you can hear all this stuff. Because in 1900, he heard about sunlight falling on a new metal called selenium and making it give off electrons, that is, electricity, as if the sunlight were knocking the electrons out of the selenium, which is basically how modern solar energy systems work. But back in 1900, light wasn't supposed to be able to do that, because light was a wave, everybody thought. Till Einstein. Light, he said, blowing physics apart, was a wave and a particle. Einstein used to explain to people who didn't understand relativity and such, most of us, thank you, that light could be both waves and particles, the same way that beer could be both beer and pints. Now, whether or not that observation leads you to a closer understanding of the dual nature of light, I won't presume to ask, but it was good enough for Einstein. There was, however, at the time, one bunch of people who got very worked up at this discovery that light could behave like particles. But they weren't exactly physicists. They were the kind of people who've been turning up to the party at Le Mans, or the PGA, or the Oscars, or whatever, since the 1920s. Celebrities. Hollywood people. But it wasn't the dual nature of light that turned them on, but because the way selenium made electricity from light meant only one thing.
Well, what are we waiting for?
Waiting for sound.
Come along, sound. We're waiting for you.
Come on, sound.
Yes, sound on film. Because if selenium were exposed to a varying light, produced by a varying current, produced by a microphone membrane vibrating from a sound going up and down, then the varying light could expose film negative varyingly, like this, making a sound track on the film. When you projected the movie, light shining on the soundtrack, down the side, came through the pattern in varying amounts. That varying light hit more selenium that generated varying current that ended up vibrating the membrane on a loudspeaker to reproduce the original sound. Hooray for Hollywood? Wrong. Listen. there still wasn't enough sound for a cinema audience to hear, until an accident happened that gave a chap called Lee de Forest an idea. Here's a vacuum tube with a filament down this end and a positive base plate at the other. Electricity will make the filament give off negative electrons that'll be attracted to the positive base plate. OK? Now remember that weak signal too small to hear on the film? You want to boost it. So, you put a negatively charged grid in. This will repel the negative filament electrons. But through that top wire, a varyingly positive input coming onto the grid will make the grid varyingly positive, attracting the electrons from the filament in surges through to the base plate. Those surges are a boosted reproduction of your input signal. Thanks to that accident I mentioned and Lee de Forest, you could hear all the Hollywood stars on the movies. Or your grandmother long distance, now phone signals could be amplified too. Or big band swing on the radio for the same reason, because radio signals got amplified too. Which was also the same reason you can hear what I'm saying now too, of course. Lee de Forest's Audion signal booster made possible contact between people no matter how far apart they were. At first, with wireless and cable, and then, finally, all this. The incredible shrinking world of TV and satellite communications. Instant Le Mans all over the planet. Thanks to Lee de Forest, it's a very talkative world. You remember I said that de Forest's invention happened because of an accident? The strange thing is, the accident didn't happen to de Forest. It had happened to Thomas Edison. Back in 1883, he was playing around with the invention he'd just come up with, his light bulb, when he saw smutty carbon deposits all round the bottom of the bulb, where he'd sealed it with a small metal base plate. With typical modesty, Edison called this strange phenomenon the Edison effect, and added it to his growing list of patents, and forgot it. By this time, of course, Edison was already world famous for all the inventions he'd thought up while he was working on the railroads. Railroads that he'd helped to make so successful, they were about to trigger the first American eco-crisis. And you don't have to look very hard at this picture to see what kind of crisis I'm talking about. You see, back in the 19th century, America was made of wood. And with the whole of the country still to open up, it was a case of plenty more where that came from. But although it takes a good few years to grow a tree, it doesn't take very long to do this to it. Unlike the people in the lumber business today, back then nobody'd ever heard of sustainability. Why should they have? Well, thanks to the railroads, they were about to. The problem was really very simple. The wooden bits holding the rails together. No big deal, I suppose, if you just say it like that. But think about what was happening to railroads by Edison's time in 1890. They were expanding like crazy. 10 new miles of track a day. Now, 10 miles of track takes 20,000 wooden ties. That's 500 trees a day. And that's not counting the wood for wagons and workers' accommodation, the wooden towns that mushroomed alongside the railroads, the wooden fuel the locomotives used, and the bridges, one of which could take 1 million feet of timber. And then there were the telegraph poles. They made a fortune for the fellow who got the contract from Western Union to put them up alongside every railroad track in America. I give up on how many trees that took, but it made him a lot of money. Enough to found a university and end up naming it after himself. Cornell. So the railroads used up a lot of wood. But back then America had plenty, so who cared? True. But since the average bit of lumber left out in the open lasts about 7 years and then needs to be replaced, well, you get the point. maybe there were going to be railroads all over America, but maybe there weren't going to be any trees. And then, at a stroke, America was saved. By gaslight, burning the gas you got by cooking coal. By the 1830s, gaslight was all the rage.
Underneath the gaslight's glitter stands a little fragile girl, heedless of the night winds bitter as they round about her whirl.
Gaslight changed everybody's life. People started going out in the evenings for the first time, to the new night shift work at the factories, evening classes, gentlemen's clubs. Above all, to the excitement and bright lights of the new rave music hall shows like this one.
There are many sad and weary in this pleasant world of ours, crying every night so dreary, won't you buy my pretty flowers?
Now, the trouble with gaslight was the byproduct, coal tar, a black, foul-smelling muck and an eco-crisis waiting to happen because all they did was chuck it in the nearest river and get back to morally uplifting songs. Then German chemists with a recycling turn of mind started distilling the black muck and got all sorts of amazing things. Brilliant artificial dyes, chemicals to make aspirin, and something that would preserve wooden railroad ties for 30 years and save America from that eco-crisis. Creosote.
There are many sad and weary in this pleasant world of ours, crying every night so dreary, won't you buy my pretty flower?
Meanwhile, you'll be riveted to know that the coal tar story continues. I'll just wait till I'm on the ground. It's an extraordinary turn of fate that even while German interest in coal tar was saving the railroads with creosote, that same interest would soon ruin the railroads, thanks to war and the weather. First, the weather. It rains a lot in Britain. So, in the early part of the 19th century, when a Scotsman called Mackintosh discovered that another byproduct of coal tar, called naphtha, would turn rubber into a solution, he knew he was going to be rich. Because when he spread the rubber between two sheets of cotton, he produced the waterproof raincoat we still call Mackintosh today. So in 1854, the Crimean War and all those wet troops made Mackintosh a million, in spite of the fact that in summer heat, his coats stank, and in winter ice, they cracked. And the reason for this Goodyear blimp is because that's who solved Mackintosh's problem. Because by that time, Charles Goodyear's amazing new vulcanized rubber was available, thanks to another accident Goodyear had when he dropped some rubber mixed with sulfur onto a hot stove, and out came a new rubber that was perfect for Mackintosh and for ground sheets for troops in the Civil War, which turned rubber manufacture into really big business. And speaking of civil wars, in 1863, a German military type was sent to America to observe the use of balloons by the Northern Army, and he got so excited he went home and invented the kind of balloon that would bring airborne warfare to civilian populations for the first time. He named the airship after himself, the Zeppelin. Its propellers driven by the new gasoline engines that would also fit into another invention that would one day eventually ruin the railroads and to make possible the 24-hour race at Le Mans. The automobile. One last twist. You remember coal tar? Well, one of its byproducts was a synthetic dye called aniline. Turned out if you added aniline to rubber, it speeded up the vulcanizing process for tires and made the tire immensely more hard-wearing. Hard-wearing enough to handle the 24 hours of punishment it has to take on the car that crosses the finishing line first. there you have it, the end of another Le Mans and the end of another programme. And as I promised, thanks to the strange historical pathway that linked tyres back through gaslight, railroads, relativity and bullets to celluloid, here at Le Mans, where I took all these happy snaps, the winner is photographed winning because he's photographed winning. That's what I thought I said.